Hi everybody, welcome to the next episode of the Pleb Dev course. I am Super Testnet and I will be teaching you about JavaScript and Bitcoin, the money of the web and the programming language of the web. You guys ready to get started? I hope you are, because we're going to do it. First of all, you can get this presentation on your own screen, on your own laptop or desktop or whatever you're doing by just copy pasting this URL. And if you do that, boom, you get a copy of this presentation, which is useful because we're going to be copy pasting code from here into your own thing. So make sure you pull this up. Once you pull this up, you can also go to the GitHub to see what it is that we're going to make. What we're going to do is we're going to complete Austin's wallet that he made in the last episode with you. And if you just take a look at this link right here, we're going to finish his wallet. And we're going to populate a list of transactions down here. We're going to show your balance. We're going to show the current price of Bitcoin. And it's going to be awesome. So that's what we're going to do. Let's get into it. All right. So what is JavaScript? Well, it's a programming language. And it's one of the most important ones because it's the only one that works on the web. All other programming languages you can install on your computer, and then you can do stuff with them on your computer. You can install them on a server and do stuff on a server with them. JavaScript works on the web. It's included in every web browser, and that's what makes it unique. It's the only one you can use if you want to do stuff on the web. It is mostly used for making websites that automatically update. So here I've got an example of a guy named Bob. Over here, Bob, he's going to make a website that has a picture of a monkey on it, and he wants to make that monkey's arm do this. Like maybe, I don't know, maybe it's waving or something. And you can use JavaScript to make it like automatically change between two images. Now, I know what you may be thinking, you could use a GIF for this. And yeah, you could. You could use a GIF instead of using JavaScript. But if you want to use a GIF, go learn from a GIF making course. This one's about JavaScript, and I'll teach you how to do it with that. JavaScript is also used for playing and controlling MP3s and video on the web, and for animating images on the web, which is the example I'm giving there, and for pretty much anything else you want to do on the web. One of the things we'll be doing with it is making a web page that automatically updates as the price of Bitcoin changes. So, cool, let's get into it. How JavaScript works. Open up your browser and go to this website, example.com. Yeah, believe it or not, that's a real website, example.com, meant for illustrating how things work. And once you're there, you need to go to your menu and open up Developer Tools. The menu of your browser is up here, and in mine, which this is Firefox, you go to More Tools and click Web Developer Tools. I've got other examples of how to get there if you're using another browser, but we need to get to this part. And then click Console. That's right there. So now we're in our browser's console, which is where you can learn how to do JavaScript. What are you going to do there? Copy paste the following code into that thing. Okay, copy that, paste it, and then hit enter. Check that out. It says, hello world, this is my first time using JavaScript. Wow, this is easy. Basically, we're using a command in JavaScript called console log, which takes some kind of text as input and then logs it into this little pane right here. And so you just use JavaScript. And I don't think it was that hard. But we're going to use that throughout this example. So now you know how to do that. One thing you can learn about JavaScript is that this is true of most programming languages. When you start writing lines of code in JavaScript into a web page, it executes from the top down. So the first line it executes is hello world, which you can see that line right here. The next line it executes is this is my first time using JavaScript, which goes in the second line right there. And then lastly, it does the third one. So we'll be learning that throughout this whole thing. The first line of code that you put on is the first one that gets written, and so on and so forth. That's JavaScript, and it's also most other programming languages as well. Two of JavaScript's data types are numbers and strings. Data types are important to learn about because they can really screw you up when you're trying to add a number to a number and it turns out that one of them is not a number. Let me show you what I mean. Copy paste this code into your browser console, just like we did the other one. And you'll notice that, at least in Firefox, I don't know if other browsers do this, I've console logged the number 3 and I've console logged the string 3. The difference between a number and a string, well, visually the difference is that Firefox shows the number in green and it shows the string in black. But what's different about them is that you can do arithmetic on a number and you can't do arithmetic on a string. So coming down to the second example here, if I try to log 3 plus 2, you can see in here, that makes 5, right? Because that's arithmetic. I'm operating on two numbers. And then down below there, if I log string 3 plus 2, well, you can't do arithmetic on a string. So instead, the plus here, instead of being an addition, it does something called concatenation, where it takes the one thing, which is a 3, and just slaps the other one right next to it and makes 32. But that's not the number 32, that's the string 32. Hope you can see the difference there. A string is text, numbers are, well, they're numbers. Another thing to note is that JavaScript has this property of dynamic or loose, I think it's called loose typing. And what's loose typing mean? Well, that means JavaScript will try and figure out whether the thing you're putting into it is a string or a number. You can specify using these functions called string and number. You can like wrap your word in that, and it'll and then you can like say this is a string or this is a number. But if you don't type anything, it'll try and figure it out. So in this case, in the top example, 3 plus 2, I didn't specify whether those are numbers, but it looked at them and said, those look like numbers to me, and JavaScript just assumed they were. But it doesn't always work, because like down here at the bottom, I specified that one of them was a string, and I didn't specify the other one, and then JavaScript was like, well, he's trying to add a number to a string. I'm going to assume that he wants the second one to be a string as well, even though I didn't specify. So just be aware that JavaScript has this property of loose typing. It'll try and figure it out for you, but it's best to specify. Like you should specify if this is a number or a string by using these functions, number and string. That's why they're there. Okay, next thing we're going to learn is about data structures. JavaScript has two main data structures, arrays and objects. What's an example of an array? Well, here's an example of an array. Let's copy paste that into our little example here and see what happens. If I paste all that, what's it going to do? I get out two things. I get out something called array, and it says it has 3 elements in it: lemons, apples, and oranges. Okay, if you click it, you can actually see them numbered here. The first element, indexed from the number 0, because that's how programming languages generally work, is lemons. And the second number is is apples. And then the third example is oranges. Okay, so that is what an array looks like. It's like you take a bunch of stuff, in this case fruits, and you make you make a data structure that can hold them, and we call it an array. And an array is indexed by these numbers over here on the left. So you can get a particular one of them. Like here, I'm just console logging the entire array, which is why I put that whole array in there. But in the second line, in this last line on here, I'm getting something from the array using index 0. When I do that, it's just going to get the 0th item, or the first item, which is lemons. And so that's why I put out lemons right there. So that's an array. We use these a lot in JavaScript as places to store information. We store information in arrays, and then we like put it on your screen at certain times or whatever. We're actually going to do that later when we get to the transaction list that I showed you. That's going to be an array, and then we're going to pop those onto your screen. Another example of a data structure in JavaScript is an object. So here's a second example here. Let's pop this in. And we get a little bit of a different thing. This is an object, which looks kind of like an array, but it has these key value pairs. Like here's a key, orange fruit, and then the value it has is orange. Key red fruit has the value apple. Key yellow fruit has the value lemon. We call those key value pairs. And what makes objects different from arrays is that instead of indexing by a number, we index by this key. Orange fruit, red fruit, yellow fruit, or whatever it is you make your keys. And that allows you, or that results in 2 properties that you have to know about when you're dealing with objects. The order that you put things in an object doesn't matter, and it's not always preserved. So for example, right here, the first one I put in was yellow fruit, but when it actually came out, when I actually used this object, it reordered them and put orange fruit first, because it decided to order them alphabetically instead of how I put them in. So if you use an object, the order you put things in is not preserved. Different browsers do different things, but it doesn't really matter because if you cared about the order, you'd use an array where things are indexed numerically. And if you're not doing that, then you can get things out by their key. You can say, I want to get the orange fruit object. So I hear the last line, get me the red fruit object. If I just do that, it is just going to print out apple. So here I'm not getting things by their number, I'm getting them by their key, which is just another, some developers find that more intuitive. I personally use objects more than I use arrays because of that property. I can mentally, I can be like, I want the red fruit, for example, or whatever it is I'm working with. Okay, so those are some of the data structures that we have available. JavaScript does have other ones, and if you want to learn more, I'm not covering everything in JavaScript here. I'm just covering some of the basics, some of the things that I frequently use. So if you want to learn more, there are resources down here at the bottom where you can learn about other data structures, other data types that JavaScript has. I encourage you to do that if you want to dive into more of the weeds. Next thing we're going to learn about is variables. A variable is a short name for a string or a number. Okay, so let's do an example here. I'm going to create a variable called message. Message is the short name, and then it's going to correspond to this longer value, which is, this is a long piece of text. And then I'm going to take that short message, and I'm going to change its value. I'm going to make it equal what it previously was, plus this additional text, which is, and I can make it even longer. Then I'm going to do that again and make it even longer. And I'm going to do that again and make it even longer. And eventually this text gets to be pretty long size, but it's all just included in this short word message. So if I print that out here and hit enter, we can see that we have this pretty long piece of text that I logged into my console here, but I just told it to log the word message. I just told it to log the short word, and then it figured out that, or it knew because I told it, that word message corresponds to this much longer thing. So variables are useful for that, so you can kind of clean up your code and chunk things out and make long pieces into shorter things that are easier to deal with. Also, the last line here says console log message plus this. This one does not set the message to have this extra value to it. It doesn't say message equals the existing message plus this extra thing. It's just logging this extra piece of text here. So even though it shows up where it says, and that's the way it really is, if I console log my message again, that last piece of text, and that's the way it is not there, because I didn't add it to my message inside the variable. I just added it after saying put out the variable and then put out that message. So you can see, if you're going to change the value of a message, you've got to use the equal sign. That's basically what that's there for, to teach you that that's what the equal sign is used for in the context of variables. Next thing we're going to learn about is functions, which are kind of like variables. They're a short name for lines of code. So if you write, eventually what you're going to do in JavaScript, if you're like me, is you're going to write a lot of code. You're going to write maybe, I don't know, hundreds of lines. And sometimes if you want to do something more than once in your code, you get to this point where you're copy pasting 100 lines at different places, and it makes your code kind of longer than it needs to be. So in JavaScript, we have these things called functions, which allow you to do the same thing as a variable, but you take those lines of code, you give them a short name, and then anywhere you want to use that code, you can call that short name, which makes it so you don't have to copy paste a bunch of code a bunch of times. You can just copy paste a function name, which is kind of cool. So let's see an example of that. I'm going to copy paste this function in here. Now you'll notice that nothing happened. I didn't tell my browser to do anything, so it returns the word undefined. And now I'm going to call, but now I'm going to call this function, because I put that function in there as if I ever call this word, a name, then run this piece of code right here. Now let's see what happens when I actually do call that function a name. I'm going to hit enter, and look at that. It ran my code. It says, look, Mom, I'm using a function. Now you know how to do that. Another example down here is a function with a variable. See, functions have these weird parentheses around them, or right after their function name. And what's that hanging on there for? Well, that allows you to insert code, variable code, into your function. Now, here's the second function called another name. You can name your functions whatever you want. Feel free to play with this and change the name to something different. But if I run this one, or just put that in there, then I can call another name. And if I don't specify a variable, what happens? Well, we get the variable I entered is undefined. Neat, huh? Because I didn't specify what to put in there as this variable word. But let me do that again and put in the word, I don't know, ShamWow. ShamWow. Now it says the variable I entered is ShamWow. So you can see you can add elements to your code. You can also, let me go back up here. Let me add a second variable. You can name the variables whatever you want. I'll name the second one cloth, and then I'll name the third one pink. And I can actually add these things to my code. The next one is cloth. And the next one is pink. Okay, so you can see that if I run this function now, another name, I can give it 3 different things. Let's try test 1, test 2, and test 3. And it duly puts them in where I wanted them. So this shows you that functions have these things called parameters. They go in the parentheses. They are comma separated, so you can add new ones using that. And then when you want to use them in your code, I've been using this notation for my console logging, where I surround the text I want to put stuff in with backticks. That little symbol right there is called a backtick. And you can, so let me show you why I'm using backticks. You can use other things. You can say console.log, and you can put in double quotations. Console log the word test. It's fine with that. You can put in single quotes, which are apostrophes. You can use apostrophes. We usually call them single quotes. And that'll also work. And then you can use backticks, which are up here in the top left hand of your keyboard, right under the tilde sign. And put in the word test, and it'll accept those as well. But if you use backticks, in fact, I recommend always using backticks because they have a couple of different properties. One is, if you use backticks, you usually don't use them in any other context, whereas quotations and apostrophes I often do. So like I wrote something earlier that said like, I'm using a function. And if you write that in with backticks, it's perfectly fine. But if you use single quotes or apostrophes, it's going to throw an error now, because the word I'm has an apostrophe in it, and so it thinks it's supposed to end the string right there, and that's not what I want, So I use backticks to differentiate because they rarely appear outside of programming, and apostrophes and quotation marks do. The other thing backticks let you do is something I showed you earlier, where I use this dollar sign and then 2 brackets, curly brackets. That's called string interpolation. And if you write a string like I'm doing here and then put that symbol in it, you can put stuff inside those brackets and it'll show up like, it interpolates your string with that. And it doesn't work with other things. So let me go back to the example. If I used single quotes here or double quotes for this, the string interpolation isn't going to work. So let's just do that, and then call this function another name, test 1, test 2, and test 3. I'm going to get an error here because, well, I guess it didn't get an error, but the string interpolation didn't work. Like the interpolator symbols show up because they only disappear if you use backticks. And so backticks has those special properties where you're not going to run into errors where you're accidentally using an apostrophe or a quotation mark in your code, and then it ruins it. And these string interpolation things let you have variables inside, which I think is great. So I recommend using those, and I use them throughout all of these examples. So those are functions. Functions are really useful. Next thing we're going to learn about is a special function called if. And if, let's put that into our code here and see what it does. I put that in and it says, I am running option 1. All right, if may look a little strange. So what does if do? Well, let's take a look here. I'm going to zoom in. What does this look like? Let's try and read it as if it was English. If 1 equals, it's 2 equal signs, that's kind of weird, equals 1, we got some curly brackets. We learned from earlier, curly brackets are where you define a function, right? That looks like kind of like we're making a function here. So we got a function that we're going to run. So console log, I am running option 1. Else, console log, I am running option 2. Okay, so this is an if-else statement. And basically you define 2 functions and you say, I'm going to run one of these. And what determines which one I'm going to run? Well, what determines it is what you put in these parentheses right here. So here I'm using something called equality of comparison, which in JavaScript, the equal sign often is like test equals 3. If I made a variable and I said var test equals 3, this is the equal sign of setting a value to another one. So now if I put in test, it's going to tell me test is equal to 3. That's what I told it to do. But if you want, sometimes in code, you want to compare things rather than set them. And so I'm here comparing the number 1 to the number 1 and checking if they're equal. And when we do that, we use a double equal sign. That's called equality of comparison. Okay, so what I'm doing here is I'm saying if the number 1 is equal to the number 1, then run this first line of code. I'm running option 1. Otherwise, run the second one. So yeah, this is what if-else statements look like. If I change this to a 2, it's going to run the second one now because 1 is not equal to 2. And the code says if it's not equal, then run the second one. Inside of these parentheses, you can't put commas anymore because this isn't, the if one is not actually a function. So you can't put commas and be like 2 equals 3, 2 equals 2. This is not going to work. It's going to give me some kind of error. Oh, no, it didn't give me an error. I guess you can put commas in. But it didn't do anything. It didn't do what I wanted. What you can do inside an if statement is you can add and conditions. So you can say, like, if 1 equals 1 and 2 equals 2, once again, we're using doubles in here, then it's going to run option 1 because both of those are true. But if I make one of them false, this will only run if, like, one of them is true. Or this will only run if both of them are true because I put in an and sign. You can also use or. You can do or like that. So if this will make it so that it'll run if either, the first option will run if either of these things is true. So let's try it. Yeah, now it's running option 1. Even though this one is false, that doesn't matter because it's only an or and the first one was true. So it's like, well, one of them was true, so I'm going to run it. So 95% of programming probably is if statements, like chaining a bunch of if statements together and being like, if this happens, then do this. If the user puts this name in a button, then do this. And if they are logged in, then you do that. And that's most of what you're doing is making these if statements. And now you know how to do them. So you're 90% of a programmer right here. All right, cool. Function for getting text from the internet. I've taught you most of the stuff that I use when I'm doing JavaScript. There's a few things that we're going to learn as we're finishing this wallet. But the one more thing I want to teach you before we get to making the wallet, which happens on the next couple slides, one more thing I want to teach you is how to get data from the internet. So this is a function that I wrote, and there are other ones. Fetch is very popular as well. But I use this one. It's called getData, and I wrote it so that I can get information from a URL. So here's an example. I'm going to type in this URL, which is a GitHub link to a text document, and I'm going to run my getData function with that. And let's see what we get. GetData, boom. We get this thing called a promise. And if you click the promise, you'll see that it has a state called fulfilled and a value called hi there. Where's it getting this information from? Well, let's check. I'm going to copy this URL and pop it into my browser and see what I get. I get this little piece of text there that says, hi there. Okay, cool. So I can kind of see where it's getting the value from. Down here, it's getting it from that text document. But what's this promise? Well, when you're getting data from the internet, it's a special JavaScript function that fires off a request and basically promises your code, I'm going to give you something back as soon as I get it from the internet. And so these are called promises in JavaScript, and it'll go off and come back, and until it comes back, the state is going to say pending. But once it returns, then you click here, and the state changed to fulfilled. Like it got the thing you wanted, and the value it got was this. So let's use another example right here. I'm going to get a piece of data called comments. This is from a website called JSON placeholder. Let's just see, before I do that, I'm going to see what we're going to get back. Paste it into your browser, and you will get this funky thing. Firefox puts it in this format for us. Other browsers might show you this raw data thing. I'm actually going to zoom in so you can see this. This is a JSON object. I'm using terms you're not familiar with. This is an object. Earlier I showed you how JavaScript has this has these objects that have key value pairs. And an object looks like, it's got these curly brackets, and then it's got these keys like post ID, and the value is 1, name is equal to whatever this Latin stuff is, email is equal to this email address. That's called an object. And the JavaScript's biggest contribution to the world of programming is probably this notation. It's called JSON, or JavaScript Object Notation. The way that JavaScript does objects and arrays has proven to be very popular, like with these curly brackets and with the quotation marks and the colons and stuff. That's how JavaScript writes these objects. And computers can read this very easily. Like, they just eat this up. When they see curly brackets like this, they're just like, I know what that means. That means an object is coming, and I can figure out what's in there using these key value pairs. Computers love this stuff, and JavaScript introduced this way for computers to talk to each other using this object notation that's also human readable. Like, a human can read this and figure out that the person's email address is this. So the use of this JavaScript object notation has become very popular to the point where, like, every other programming language has implemented support for parsing these things. And now it's just like, if you go get data from a website, you're usually getting JavaScript back, JavaScript object notation text. Also notice that there's an array here. These square brackets delineate an array. That's what I showed you earlier. But you can put objects inside of an array. And so here we have an array of objects. It's like the first thing is the array, and then there's a bunch of objects inside of that array. And that's very common. So you would get each of these things by a numeric indicator. This would be number 0, and this would be number 1, because that's how an array works. In fact, I will show you that in the next slide. But in this slide, I want to finish with this. One thing is that if I put that code into here, into my console, we're going to get back a promise with the value stringified in there. These /ns mean new line, because the code has new lines right there. And in JavaScript, we show that with a /n. Anyway, this value stuff is kind of cool, but how do you get it out of there? How do you get the data from that promise? Well, you use this. You created a variable called data, or you can name your variable whatever you want, and then you put a weight. And if you put a weight there, it'll get the it'll pull the value out of the promise. So if I do this, it'll do that and show you what your thing is there. It also puts slashes in front of the quotation marks for displaying it in here, so that because your browser would get confused if it saw quotation marks, it would think those are string delineators, but they're not. They are keys, so it puts slashes around them. But those won't show up elsewhere. I will show you what I mean by that on this slide. So I'm going to run that same code again, get that value, and I'm going to create a new variable called machine readable data, and I'm going to do something called parse, parse the data. So let's see what happens. If I do that, it shows me that the information that I pulled from that website has now been turned into an array, right? An array that their computer can understand, and it knows there are 1, 2, 3, 4, 5 objects inside of that array. You can kind of see them all. They all have their indexed by numbers, which is what I showed you I'd show you. And then each object has information, key value pairs inside of it. But now that it's machine readable, we can do things like get the second one, get the second object out of there using our array notation, see? And that just gets the second object. Now that we have the second object, we can do something like get the key, or get the value of the key email. So if I do that, it should give me, what's the person's email? Nikita@garfield.biz. Look at that, Nikita@garfield.biz. So this is a lot of programming is just like going to some website that puts information in a JSON for you, and then like show it on some other website, which is what we're going to do. We're going to show the Bitcoin price, and we're going to show the balance of a wallet. But that's a lot of what you're going to do as a programmer, is like learn to parse these APIs and get information from the internet. And now you know how to do that. You get data using the getData function, or some other one. You can learn about other ones on the resources that at the end. You turn it into a variable, and then use the array and object syntax to get items from those arrays and from those objects. Cool, right? I hope so. I hope you think so. One more thing I want to show you is about why we use this await thing. Okay, so let's pop this function into our script here, and then let's use it, get stuff from the internet. What we're going to see is, first it's going to run this line. Remember, we're running lines run a line, then we run a line, then we run a line. That's how JavaScript works. Running this line, first I'll log a message. It does that. Then it gets this promise, var data equals get data. And you'll notice I didn't use await, so we get this promise thing here. And then I say console log the data. Well, it didn't do that, you'll notice. It didn't actually log the data, but in fact, it went right along to this third one, which says console log, lastly, I'll log this other message. And that's the next thing it did. So why did it skip this line? Well, it's because JavaScript really likes to hurry. JavaScript is intended to be a very fast programming language. And the moment you load your page, or in this case, the moment I hit enter, it ran everything in here all at once. So it fired off this right away. It fired off the request to go get data, because that's the next instruction. But when it ran this line, console log data, it hadn't gotten a response back because it didn't wait. Like JavaScript's not going to sit there and wait for a response to come back. It's going to proceed right along and run the next thing. And that's what the await keyword fixes, right? So if I redo this, if I just change that function slightly to put in the word await here, it's going to change everything. Actually, I'm going to get an error, and I'll show you the error. I get an error that says await is only valid in asynchronous functions. So what's an asynchronous function? An asynchronous function is one that has an await in it. And it's called asynchronous because it's got a time thing happening in it. Like synchronicity is a word that means basically wait. It means wait. And so what this function is doing is it's got the await keyword in here that's saying, don't proceed to the next line, Mr. JavaScript. I know you're in a hurry, but wait for this information to come back. And JavaScript is saying, well, if you're going to do that, you need to make this an asynchronous function because asynchronicity was added much later in JavaScript, much longer after it was created. And it was because people wanted it to wait. Like JavaScript's too fast, and programmers wanted it to wait for things to come back. So if I do this now and then call get stuff from internet, I've changed it into an asynchronous function and added the await keyword, and now it does what we expect. First, it got the message, then it logs the result, which is the phrase hi there, and then it logs the last message. So this time, what the difference between our previous one, which is up here, is it waited for this information to come back, for this promise to resolve, and then it proceeded. Okay, so now you know a little bit about asynchronicity and await. I recommend that if you always use asynchronous functions, and then you don't have problems with things like breaking. You can, even if you don't use the await keyword, you can still make a function asynchronous, and it's not going to hurt anything. But yeah, I just recommend always doing that. Make all of your functions asynchronous, and you'll never have any problems. Yeah, right. Okay, cool. Next thing we're going to do is make the wallet. Let's do it. First, go to GitHub, and Austin helpfully taught you how to use GitHub. So I can just tell you that we're going to use Git to clone this project that he made. So let's open up our terminal, because you're all programmers now and can do git clone this project. We're just going to create a full directory called learn CSS, and it's going to copy all those files into there. Let's go and see in our file explorer. There's a new little directory right there. Look at that. It's amazing. I love Austin. He just knows how to do the coolest things. And now I'm going to open up this in my text editor. This is the wallet y'all made last time. And I'm going to open up in my web browser. Open with Firefox. And you can see it's got some incorrect data in here. It's got the wrong Bitcoin price. Bitcoin's price is not currently $19,000. It's currently $16,000 something. And it's got a wrong balance. It says that we have almost 1 million sats, and we don't, because we don't have a wallet open up. So we're going to fix this and finish this wallet and make it pull accurate data from the Bitcoin network and make it do stuff. First thing we're going to do is make sure we can edit stuff in this, or make sure we can actually do stuff in this document. Let's go down here to the footer, and I'm going to make this bigger so you can see what I'm doing. And I'm going to pop in this console log script. When we put JavaScript into a web page, it needs script tags, or into an HTML document, I mean. It needs script tags. Everything in HTML has to be embedded inside tags. And if you're using JavaScript, there's these special tags called script that let you, well, put JavaScript into them. So I'm going to save that, refresh this, and do you see any changes? I don't see any changes because the only changes are going to show up in our console where we suddenly have the word test, just like we wanted. All right, cool. So we can actually change stuff in this browser, or in this web page. We can put stuff in the console. Now, let's put stuff in the wallet. Next page on here, I'm going to teach you about DOM manipulation. What is DOM manipulation? Well, my friend, HTML, this system of tags and stuff is represented in JavaScript through something called a document object. Remember how I showed you objects earlier? Well, everything in JavaScript is basically an object, including an HTML page. And so all of these tags, all of these elements, the meta elements, the title elements, they get turned into key value pairs, where the key is like header, and then the value is, or the key is h1 in this case, and the value is pleb wallet. Or the key is header here, and there's like another object inside that has this whole string in it, or this whole additional object, which is h1 pleb wallet. Anyway, this is the document object, and when we modify it or manipulate it, that's called DOM manipulation. A long time ago, in the, I think, late 90s, it was probably early 2000s, there was an invention called jQuery. And this invention was a way of writing JavaScript that made it slightly easier compared to how we did things before. Before, when we used to do document object manipulation, we would create a string that was like, we would specify the document as what we want to modify, and then we would specify an element within there. We'd say like get the div element that has the class buttons, and then we would put another dot notation on there, and we'd say, and then get the thing called buttons. And they made these very long queries to whatever thing we wanted to modify. And so these jQuery people came up with a simplified way of doing this. Using these dollar signs, which aren't used for other things in JavaScript. So they purposed them for getting information. And basically, we would create these two variables called query selectors that are bound to this document so that the browser doesn't use them for things in other parts of the browser. And what we do is, if we put these in our code right here, this allows us to get items in our document using this dollar sign notation. So let me show you the dollar sign notation. I'm going to get, let's do this h1, or actually no, we'll get that h1 right there. So I'm going to say get h1, and I get an error. Dollar sign is not a function. That's not what I expected. Let me put that. Maybe I got to do it inside my code. So let's go into down here and say console log that. Refresh. Oh, I never did that. I never defined those keywords. So here, we define the keywords, save it, and refresh, and it actually pulled in this document object for us, which is the header. And if we click it, we can see there's a bunch of stuff the header doesn't use. But one of them is it's got some text in it. And in fact, it's got the text pleb wallet in it. And we can use that to change stuff. So I'm going to pull in this example, I'm going to pull in the first balance card, which is down here. This is a balance card. And I'm going to get balance card 1. Okay, so let me show you what this balance card thing is. If I use double dollar signs in here, in my code, and console log a double dollar sign, it will get every element that has balance card in it. Let me get rid of the P to show you what this does. It'll get every element that has the class balance card. We're inheriting from CSS, this dot notation where you specify classes using a dot. I'm going to save and hit refresh, and what do we get in here? We get something called a node list, which is an array of objects. And the first object is the first thing called balance card, which is this one on the left-hand side of the screen. And then the second one is the second class that has balance card, which is that one. Because you can see in our HTML, there are two items that have the class balance card. So the double dollar sign notation makes an array of them. And the single dollar sign, when you're using this notation, gets the first one. Just gets whatever the first one is. So if I change this down here to $1 sign, right here, it's going to get us the first one, the first balance card right there. If we then further specify a p tag, just like in CSS, this will get us an array of all of the p tags within balance card, the balance card class. So here it's 2 p tags. One of them has a number of sats in them, and the other one has Bitcoin price in them. Well, let's modify that second one here using this code. We're going to index, remember JavaScript indexes from the number 0. So when we put the number 1 in here, it's actually getting the second one. And we're going to change its inner HTML to test. I'll pop that right in there. Save, refresh the page, and we got an error. Console log is, I shouldn't have put console log in here because I'm not logging to the console anymore. I'm actually putting stuff onto our page. So I save, refresh, and check that out. It's been changed to the word test. So we now know we can modify things on our page using document object manipulation. All right, cool. Well, let's change it to the actual Bitcoin price then. Let's put our getData function into our code. I'm just going to make a new script tag here, put it in, and I'm going to indent it properly. Indenting properly saves you headaches later, so I recommend doing it. JavaScript doesn't actually care if you indent things, though. All right, so I'm still specifying that it should be called test, but let's now make it so that instead of making it the word test, let's call this getData function and actually get Bitcoin's price. I'm going to get it from Coinbase. So here I'm creating a function called getBitcoinPrice, and what's it going to do? GetBitcoinPrice is going to fire off a query to Coinbase using our getData function and use the Coinbase API to get Bitcoin's price. So if I paste that into my browser, it's going to get me this JSON file, which I'll just open, and you can see there's a JSON object here. Remember how I told you computers talk to each other with this JSON thing? Which has 2 objects in it. The first object is the word data, with a second object as its value, and the second object has 3 key value pairs in it. The base currency that we're talking about is Bitcoin, the currency of comparison is USD, and the amount is $16,725.45. So, using JavaScript, I'm going to pull that data, I'm going to parse that JSON, turn it into a variable called JSON, and then use my object thing to go into the data object, which is this one. I'm going into the data object right there, and then I'm pulling out the amount value. So here's the key amount, and there's its value. So if I do that, copy that. Oh, I think I already pasted it into my code. Yeah, so now I'm going to call this, and what's going to happen, I believe, I'm going to get an error. Let me show you why. Get Bitcoin price. Also, I got to put my await in here. I'm going to get a couple of errors. So I'm going to save this, refresh the page, and look at this. Oh, that's not even the right page. Pleb wallet, refresh, got an error. Await is only valid in asynchronous functions. This is why I told you to make all your functions asynchronous. In fact, this right here, where I'm actually trying to use await, is not even a function. I'm just putting code straight into the document right there. Let's turn that into an asynchronous function. Got that right here. Just gonna copy that and replace the old script with no function in it with this new one that does have a function. I create an asynchronous function called app, and I'm getting the price of Bitcoin. And now, since I'm awaiting it, I shouldn't get any errors. Then I'm taking this price and turning it into a number, making sure it's a number, because it's important to do that in JavaScript, otherwise you might get a string. Then I'm going to take that and use this toLocaleString function, which puts commas in it. That's what toLocaleString does. Once again, I'm not showing you everything in JavaScript. Like I didn't show you, until now, I didn't show you this. There's a bunch of stuff like all numbers and all numbers in JavaScript have this this thing called a method, where they have a bunch of methods, but one of them is the toLocaleString method, which puts commas in where you need them. And it'll do that based on your local region, how your local region uses commas. Not everyone uses yeah, never mind. Fresh. So when I do that, oh, I did get a promise. Get Bitcoin price is not defined. Of course I got an error, because this is what I wanted to show you earlier. When you use a function like this, it matters where you call it. So I'm calling the function app right after I created it. And in JavaScript, it's going to execute this line of code as soon as it gets to it. And that happens before it's loaded the rest of the page. Like, pages load line by line, just like JavaScript executes line by line. And I'm calling this app function, which uses this get Bitcoin price thing. I'm calling it before this get Bitcoin price function has loaded. So it's giving me this error saying there's no get Bitcoin price function, because when that runs, there wasn't. So how you can fix this, you could just take this and put it at the bottom of your document, but I'm going to do one better and take the entire script and put it at the bottom of the document. Save and rerun, and now it's actually got the real Bitcoin price. Put a $sign in front of it, put a comma in, put the dot in. Well, the dot was already there. And then we got it. So yeah, check this out. Here is what it took. $16,725.45, or whatever the current price is. And then it added this comma. That's what toLocalString method did. And then the $sign got added because of this little line right here, where it says put a $sign in front. Okay, so now we know how to modify our web page and put stuff into it. Next thing we need to do is, well, the Bitcoin price keeps changing, right? It's already changed. It's not this anymore, because the Bitcoin price fluctuates constantly. And so I would like this web page to do that too. So I'm going to do something called set timeout. This is something I'm adding to our app document. And what does set timeout do? Well, it says to run a function after you wait a little bit. And you specify how long you wait over here in milliseconds. So I'm telling it wait 10,000 milliseconds. That's what the timeout does. Wait 10,000 milliseconds, or 10 seconds, and then run a function called app. Well, where's the app function? That's just this again. So by putting this into my code, I do something called a loop. I create a loop so that it will just keep on running this function every 10 seconds. It'll keep on getting the price every 10 seconds, turning that price into a string with commas and a $sign in front, and then sticking it into our balance card. So copy this whole line, paste it into down here, indent it properly, save, refresh, and now every 10 seconds it'll get a new copy of the Bitcoin price and just cyclically loop around and change this value again so that we have a constant updated Bitcoin price. Cool, so it just did it while I was talking there. You can see I highlighted this, and then after 10 seconds, my highlighting went away because the thing changed. And yeah, so apparently the Bitcoin price is stable for the last few seconds and hasn't changed itself. But my document is changing every 10 seconds now. And that's the power of loops in JavaScript, or set timeouts. Next thing we're going to do is modify our getData function, because we're going to get some data from a wallet. Before I do this, I'm going to create a wallet. LNBits is a website where you can create Bitcoin wallets online and put money in them and do Bitcoin stuff. Once you go to lnbits.com, click Legend, which is one of the example servers here that's running one of these online wallets. Create a wallet called, I don't know, Pleb wallet. Let's call it that. And we get a little wallet over here that we can put money in and take money out of. And why I'm using this wallet is because it's got an API. Remember I told you about APIs earlier? I'm going to use an API to finish Pleb wallet and make it get information from here. Okay, so the API in here shows you a couple of things you need to talk to this wallet, which are these things called keys. You need these admin keys. Then it gives you details about how to use this API. For example, over here, let me zoom in. Zoom, yeah. For over here, it says that we're going to fire off a GET request to /API/v1/wallet. This is shorthand in developer talk. This means we take our current URL, legend.lnbits.com, and we add on this value to it, /API/v1/wallet, and that's going to be our API endpoint. That's the thing we have to query to get data. And then it's telling us that we need to pass headers. We need to pass an API key header to our document, which includes this password. You can use either the invoice password or the admin password. I'm actually going to use the admin one to get data. In order to pass that password to it, or the API key, we need to modify our getData function so that it can pass headers. When I previously made this getData function, I only told it to call out to a URL, But with LN bits and with other APIs, very often you need a password. And so we need to pass that to our document as a header. So this will let us do that. I'm going to stick this code right under the word open. And so where's open in our getData function? Right there. We're going to paste it in right there. And now it'll add in any API headers we need to talk to LN bits. Oh, don't need the word send in there twice. Save that. And now we can create a function called getLNBitsBalance, which is very similar to the Coinbase one, but it's going to fire off a query to the API. See, legend.lnbits.com. That's the URL we were on, legend.lnbits.com. And then it's putting on the API info, /API/v1/wallet, which is right here, /API/v1/wallet. And what this will get back for us, if we pass in the proper password, which is this one, admin key password, it's going to get for us a JSON, because that's how computers talk to each other, and get the balance from it. Let's stick this function in. And I'm just going to stick that right under my getBitcoinPrice function, because it's very similar. Save it. And let's add this to our app so that it will get our balance from LNbits, from our LNbits wallet, and then change the balance of our change the balance card to reflect that. Paste that right there. Actually, let's paste it first because it's using the first balance card, indexed by 0. Now, if we refresh our page, then every 10 seconds, it should get, oh, no, we got an error. API key is not defined. Yeah, because I forgot to add to our URL that we can now pass an API key and a content type. What is the content type? Sometimes when you're making these requests, you need to specify that you want JSON back, and that lets us do this. In this case, the URL does not require us to do that, but I recommend putting that in there in case you need it in future projects. So we refresh, and now, look at that. 0 sats are currently in our wallet. Okay, cool. So we got the Bitcoin price, we got our current sat balance. Next thing we need to do is populate this transaction table so that it has our transactions in it. So let's do that. We're going to get an array of LNbits transactions using this function. And it's very similar to the last one, but it's calling another endpoint on this, on this API. And this one requires that we specify that we want to get JSON back. Computers can talk to each other in a number of different formats. They can talk to each other in JSON, in CSV, and in plain text, and a couple of other ones. We want JSON. So we tell our application to give us JSON back, and now we're using that third content type thing where we say, give us JSON and not like a CSV file or something. Then it's going to give us a list of transactions when we query this endpoint, and that's what we're going to do. We're going to use that. We're going to use that right here. So we're going to create a variable called transactions, wait for this thing to fire back, and then I'm using, so I create, what it gives us back is an array of objects. Each object is a transaction, and an array is in there. And I'm using a method, an array method called forEach. So let me show you what forEach does. ForEach allows you to specify a function that you want to run every time it sees a new object in your array, or a new item in your array. So for each function, or for each transaction rather, I'm going to pass it into a function that I create right here, which is an if-else function. It's going to get the amount of that transaction. Well, actually, let me do this first. I'm going to show you what the transactions document looks like. I have to save this, refresh the page, do that. And, well, of course, there are no transactions. I'm going to send some money into this wallet. Let me go to Telegram, open up my wallet, LNTXbot. I've got a wallet on Telegram that I like to use. And I'm going to create an invoice in here for 50 sats. Copy that, paste it into Telegram, pay now, and my wallet here is going to put some money into LN bits. Now notice that because we're querying every 10 seconds, this should show up. Yeah, 50 sats are in my wallet now. Okay, so if I run this function, then you can see that now I've got an object inside my array, and the object has some information in it about that transaction, including this field right here. See how that says 50,000? Well, we actually only wanted to show 50 sats instead of 50,000, because in the Lightning Network, we measure things in things called millisatoshis, which are 1,000th of a sat, and so there's like 50,000 of those in 50 sats. But we're gonna change that. All right, so let's go back to our program, regularly scheduled programming, and I'm going to pop all of this information into my app function. And notice how it says close this for now, but we'll put more stuff in the next slide. I'm going to do that, and I know that this part's rather complex, so we're going to walk through exactly what this code is going to do right after this. One more tab, save. Okay, cool. So now we are doing stuff with our transactions. And what are we going to do with them? Well, let's refresh and see. If I refresh this, this shows my balance, shows the current Bitcoin price. And now there's something in this transaction table. All the way down here at the bottom, it shows that I received some money using this invoice. I received 50 cents. All right, well, I'm going to tell you how it knows that in just a second, but first let's get rid of all this dummy data. So I'm going to go into here, go into Austin's code, and get rid of everything in the transaction table, all that dummy data, except for the header transactions. And now if I refresh, it's just going to know about this one transaction that we received. All right, so let's take a look at this. What is the code doing? Well, it's getting an array of transactions, and then when it gets their amount, it divides that amount by 1,000, so that, you know, if it's 50,000 sats that came in, 50,000 millisats, it turns it into 50 sats, and then it floors that, so that if there's anything left over, like if it was 50,140 millisats, the 143 millisats just isn't going to show that in the wallet because I don't want to. So what is going to so after it gets the amount, then it checks whether it's positive or negative. That's what this part does. If positive, and then if negative. If it's negative, then LN bits represents negative amounts as expenses. So we're going to do some stuff with expenses down here. But if it's positive, it is just going to get a paragraph tag that we created right here. I see this transaction class is going to have this data object which you can use to check the data of this transaction. And if the transaction is pending, it's not going to show it. That's why I have this exclamation mark here. That means not. As long as it is not pending, then this function won't run. Or unless it is pending, unless it is not pending, this function won't run. And then it'll get an item from our row, which is right here. This is the class. Where's the class row? Transactions. It's going to get this one right here, class row, row item, and then add something to it. What does it add to it? It adds the transaction data. It adds a transaction right there, gives it the checking ID, which is like the identifier for that transaction, and it says that it received it using that invoice. So this information all comes from our API. If I look into here, we've got the invoice that I received the money with, we've got the amount that I received, and we've got the checking ID, which is like the identifier for that transaction. So cool. That is all the information we put into there. And then the one down here does the exact same thing, except it puts a negative sign in there if it's a negative payment, and it says sent with this invoice instead of received with it. Okay, the only other thing that's in here is this pre-image part, which says like, if there's a pre-image. This is something that the Lightning Network uses, and you'll learn about this in future lessons. Pre-images are how you can tell whether a payment has been completed or not. They're like a proof of payment is what some people call them. And in LN bits, if you don't have one, then it's set to all zeros. So I can see that a payment was sent if I get a pre-image. It's not all zeros, and that's why I check that. Okay, cool. So that is what this function does, and now we have a wallet that fills this out. The only thing left is to make this wallet send and receive, which Austin's wallet just currently has these basic send and receive functions that just console log that, and we're going to make them do something else. We're going to make them not just alert, send, and receive. We're going to make them open up things where we can put data. So that's what we do here. I'm creating a div, and don't tell Austin, but I'm using inline styles. If you're fixing this later, if you're finishing this wallet, you should change these to not use inline styles. We're going to make it a class called payInvoice. And it's basically just going to be a white box that opens up and lets us paste an invoice in. So let's just see it. We're going to put this right under our buttons. Save it. And then we're going to add buttons, or we're going to add on-click elements to these buttons that open up that div. So we will just create new script tags down here at the bottom. And paste in our code, save. And what's this going to do? It's going to open up that div we just created when we hit send. There it is, and close it. And then if we receive, we can enter an amount. Cool, so that is what it did. Then what is inside of those divs? Well, we need to make functions for those as well. So that when we post an invoice, we can tell LN-bits to pay that using this post JSON instruction. And if we paste an amount, then it'll get an invoice for us. And you can learn how to use all of this by just experimenting with the API on LN-bits. But I've already written out these functions so that I can just show you how to create this. So let's just pop them in. Actually, that one should go with our getData function because it's very similar. So I will just do a post here. Posting in JavaScript is pretty much the same thing as getting, except you pass data to the server instead of getting data to the server, and we call it post. And then the server will give you information back. And then we're going to put in this getInvoice function. Just pop that right in here. Save it. And for this one, we need to get our current password, which is here, our API key. Great. And the last thing we do is we're going to create a function called submitInvoiceToPay, which reaches out to, which uses our postData function to send an invoice to LN-bits that we want to pay whenever we want to do that. So we'll put that right under the getInvoice function. Save. Change our API key to the current one, save. And now our wallet is basically done. We can click receive and type in an amount such as, I don't know, 60 cents, submit, and that shows us an invoice right here. I'm going to pay that using Telegram, pay now, enter, and this is going to tell me that it paid the invoice, or at least it should tell me it paid the invoice. Great, it did. If I come back here, we should see this jump up to 100 sats. We should see a new element right here, 110, because I paid 60. And we can also send. We can like, let's say we create an invoice for, I don't know, 10 sats in here, and now we should be able to pay that right there. Do you want to pay this? Okay. Yeah. So our wallet is done now, and now you know how to use JavaScript to create a Bitcoin wallet. Lastly is some resources on JavaScript in general. I think this W3 Schools is great for teaching you more about JavaScript. You can learn all sorts of the tricks that I skipped over in here. And then we've got the developer information on Mozilla, which teaches you a lot about what JavaScript is and how it's used. And one of the things I didn't go over was loops and iteration, but you can learn all about that here. That is something that a lot of people use. So anyway, I hope that you had fun learning about JavaScript today and making your first Bitcoin wallet. And thank you for watching the latest lesson in the Pleb Dev course.